Hello everyone, welcome to my channel Physics Tricks. So let's start with new topic, and that is scalars and vectors. So in this scalars and vectors, you have to firstly understand what is the definition of scalar and what is the definition of vector, right? So firstly we'll see about the scalar. So scalar is very simple quantity. It is a physical quantity, right? So physical quantities are basically divided into two parts, that is the scalar and vector, right? So we have fundamental as well as derived physical quantities, but further we can divide it into the scalars and vectors, right? So what is scalar? It is a physical quantity which can only be represented by its magnitude, right? So it do not has any direction, right? So though it has a direction, that direction must be in particular direction, right? That is the specified direction. So we can write scalar definition as it is a physical quantity which can only be described by its magnitude, right? So it is the physical quantity which can completely described by using magnitude, right? Magnitude only, right? Magnitude only. So those quantities which can only be described by using the magnitude, that is called as the scalar quantity. Scalar quantity, magnitude as well as one unit is there. So let us suppose what are the examples. Examples of scalars are, number one, we have mass, right? So mass means we have, let us suppose we have 1 kg of sugar. So 1 kg of sugar indicates the complete statement, isn't it? 1 kg of sugar. So this 1 kg is nothing but the mass, isn't it? So this 1 is the number, this kg is the unit. So this number, that is magnitude as well as unit, both combines and we can define completely one quantity, and that quantity is nothing but the scalar quantity. So mass is a scalar quantity. This quantity is described completely by using only the magnitude, right? Likewise, second one, we have current, right? So current, though current has a direction, right? So we know that this is the, let us suppose example, 1 ampere, and this is 0.5 ampere, this is 0.5 ampere. By using the Kirchhoff's current law, we can say that if this is 0.5, this must be 0.5. This angle is theta, that is equal to 37 degree. Now this two combine directly, right? Directly, that is 0.5 plus 0.5 is 1. It is not vectorially. The two vectors at an angle 37 degree gives you some other result, right? Some other result. So this current is a what quantity? Scalar quantity, right? So current is a scalar quantity. Why? Because it does not obey the vector laws. Though it has direction as well as magnitude. Third one, we have distance, right? Distance, then speed. 1 meter. If I say 1 meter, now in which direction I didn't say, right? So that means that is called as the distance. Only the length I specified, right? So that is the distance. Then we have speed. Then we have work, right? Work is nothing but the dot product of force and displacement. So force dot displacement gives you work, right? So that is also a which quantity? That is the scalar quantity, right? So this is it is a physical quantity which can completely describe by using its magnitude and unit, and its unit you can say, right? So this is the scalar quantity, and these are the examples. And scalar addition can be done by simply, so example of scalar addition is like 1 kg of mass added with 2 kg of mass will give you 3 kg. That is the simple algebra, right? So this is called as the scalar addition. Okay. So likewise, but you can't add 1 kg of mass with 2 meter of length. Why? Because the physical quantity unit for for addition units must be same. So you can't add 1 kg of suppose sugar plus 2 meter of length is equal to how much? This is an invalid question. Why? Because these two quantities must be same quantity. That means this is mass, this must be mass, or this is distance, this must be distance. So this is not a valid question, right? So this is the wrong question, you can say. So this is all about the scalar, right? Now we'll see what is vector quantity, right? So what is vector? Vector is a physical quantity which can be described by magnitude as well as direction. So it is a physical quantity which has both magnitude as well as direction, which can be completely described by using magnitude and direction. So it has number 1 magnitude, number 2 direction, and number 3, this is a very important point, right? This third point is the very important point, and that point is it must obey the vector laws, right? So this is very important point. It must obey vector laws. If this law is not obeyed by any quantity, then that quantity is not a vector quantity, right? So this must obey the vector laws. So what are the examples? Now this definition is very clear that it is a physical quantity which has magnitude, direction, and it must obey the vector laws. Scalar is a physical quantity which has only magnitude and a unit. Right? Vector is a physical quantity which has magnitude, direction, and it must obey the vector laws, or it can completely describe by using magnitude, direction, and this must obey the vector laws. Okay. Now, what are the examples of vector? Number 1, we have force, right? So force is a which quantity? It is a vector quantity, right? It has magnitude as well as direction. 2 Newton force. If I specify 2 Newton force, but in which direction? 2 Newton force on this plane in perpendicular direction, isn't it? So we have to define the direction, isn't it? Why? Because see, if I apply a 2 Newton force in this direction, this pen will go in right hand side direction, right? And if I apply this force in this direction, this pen will go in left hand side direction. So direction of force is important, right? So force is a vector quantity. Likewise, second one, in this many student has a doubt, right? Area is a vector quantity. Why? See here, this is a length, this is a breadth. So this length into breadth will give you area, right? This is a closed surface area. Let us suppose length cross breadth will give area vector in this direction. So this area is a vector quantity, but volume is a scalar quantity, right? Likewise, next we have acceleration, right? Acceleration is a vector quantity. Number 4, torque, right? So torque is a vector quantity. Number 5, displacement is a vector quantity, right? And we have time is a scalar quantity, right? Why? Because see, though time has a direction, right? From past to present to future, then it is a scalar quantity. Why? Because this has a fixed direction, past to present to future. This time has a only fixed direction. Those quantity which has a fixed direction is the scalar quantity, like pressure, thrust by area, right? Thrust means perpendicular, normal force, right? So that normal force has a fixed direction, right? So that is why the pressure is a scalar quantity, though it is a tensor and all, yeah, that you will study in higher standard. But this, see here, this is past to present, present to future. This has a only fixed direction, so that's why time is a scalar quantity, right? Scalar quantity. Then current has a direction, but it does not obey the vector laws, right? That's why it is a scalar quantity, right? Okay, so this is all about the vector. After this, we'll study about the addition of vectors in next class.